Okay, this is another type of problem. It's called staffing or scheduling. This is when you have, they tell you you have a place and it's open 24 hours. So this is scheduling. So here, remember each worker working in this restaurant, they must complete 12 hours. They divided the shifts into 6 different shifts. Each shift is 4 hours. Shift number 1 starts at 6 a.m. to 10 a.m. Then shift 2 from 10 to 2 p.m. Then 2 p.m. to 6 p.m., 6 to 10, and they give you all the information. They tell you how many people required in each shift and the fact that you're minimizing total staff. It could also minimize cost. I'll talk about this. Now, the way we start with defining the variables, and this is how we define the variables for the staffing of the scheduling problem. We say let x1 be number of staff starting and whatever the time of shift 1, the starting time of shift 1 is, 6 a.m. x2 would be number of staff starting at 10 a.m. Number of staff starting at 2 p.m. Then you have 4, 5, 6. And that would be starting 6 p.m., 10 p.m., 2 a.m. And if they say minimum total staff, so basically all you need to do minimum total staff, you just add them. So you say x1, x2, 3, 4, 5, and x6. Now, you had something similar in the last assignment for this type of model, the staffing, but it wasn't minimized total staff, it was minimizing cost, but they told you the group working here, they take, say, $10 an hour. The working here, they take $4 an hour. Here, they take $5, whatever. So what you do is, if they tell you what the amounts are, you put it here. So if they say $10 an hour, and that's 4 hours, so $40, you put $40 for X1. Here they say $8 an hour, 4 hours, 32, you put it here. So you put the dollar value for all of these. Okay, so we got this. Now the subject 2. Now watch how I'm gonna do it. We're gonna take into account what's required, but now watch how I'm gonna do it. So they tell you, at 6 a.m., you have the X1 group starting. This group, if they start here, they only do 4 hours because this shift is only 4 hours. You need to complete 12 hours, so the same group will appear again here and here. So they do 4 hours, another 4 to complete the 12 hours. Then you have another group starting here. They do 4 hours, they come again here, and then they finish work here. You have X3, they start at 2 p.m., so they start here. They'll come again here, and they'll finish work here. You have the X4 people, they start working here. They come again here, they finish work here. You have the X5 people, they start here. They do 4 hours, they come again here to do another 4 hours, and they finish work here. And then you have the X6 people, they start working here, they come again here, and they finish work here. Once you have this done, you're ready to put everything together. For the subject 2, the constraints. Subject 2. Shift number 1. You have the X1, X5, X6 people. They need 6, so you need to have at least what they want. Shift number 2. You have the X1, X2, X6 people. They need 14, at least 14. Shift number 3. You have the 1, the 2, the 3, and you need to have 8. Shift 4. You have 2, 3, 4, they need at least 20. Shift 5. You have 3, 4, 5, at least 6. And finally, shift number 6, you have 4, 5, 6, at least 4. And remember, all variables greater than or equal 0. And only for this problem, staffing, we say and integers. This is the staffing question. So what you have left, you have the multi-period production, the blending, and the project selection. Thanks.